Welcome to the GÉANT Open Science Infoshare series. Objective of these Infoshares is to show you the wide range of topics within open science. And I think the first thought of many people when you talk with them about open science clearly is open access and publishing. And yes, that's correct, but it's only one aspect. There's much more behind open science than only open access. And in this Infoshare series, we will give you an introduction to open science. That will be our objective for today. And in the following months, we will introduce other aspects of open science in more detail, such as research data management, online publishing, FAIR principles, and we'll also take a look at the services provided by OpenAI and EUDAT. There will be info shares in November, December, and January, always on a Wednesday, starting at 2 o'clock Central European summertime or wintertime, also 2 o'clock. And please reserve about 2 hours in your calendar. So we have presentation afterwards, question, answers, and discussion. Now back to our objective for today, the overview about open science. And we have Sarah Jones, GÉANT's expert in open science, is already waiting with her presentation. And there will be plenty of time for questions and answers and time for discussion afterwards. So let's start. Sarah, stage is yours.
Excellent. Thank you very much, Leonie. So for those of you who I've not met before, I'm new to GÉANT. I came here a couple of months ago, moving to the Amsterdam office from Scotland in the UK. And my background's in research data management and open science. So I trained originally as an archivist, and then I've been working with universities, helping them support researchers with data management. So I've done a lot of work kind of with research groups, understanding their needs, and also with kind of university research offices and libraries and IT services. And more recently, I've been involved in the European work in terms of EOSC. So I work with Catherine on the exec board, and I've done work with the Commission on the Fair Data Expert Group before. So what I want to do in this session, we've got an hour and a half and I've only got 25 slides. So my presentation's not going to take too much time. And I've got 3 sections to it. So I talk initially about the relevance and, the general concept of open science. And then I'll talk about, some of the practicalities of, what it actually means to make something published to open access or to make data open and some useful resources. And then I'll close with a kind of session on, potential roles for NRENs. And I'd quite like it to be interactive. So as we go along in each of these 3 sections, I'll pause then so that we can take questions as we go. And I'm very happy for you to interrupt me if I speak too fast or if I go over a concept that, it's not clear. By all means, raise your hand or just speak out. We're a small enough group to do that. So to get started, I wanted to first think about the relevance of open science and why this is important in general, but specifically in the NREN context as well. And the concept of open science, I don't think is really anything new. Science has always been open. The way that people conduct research is collaborative. It's about, interrogation. It's about working together and collaborating and testing results. So actually, this quote here comes from Ewan Birney, who's a biologist. He says it's never been acceptable to publish papers without making the data available. You should always be able to evidence your results. And I think what we've really seen happening is that the world has changed, technology's changed, the ability to share data is different nowadays to in the past because the scales that people are working at, the amount of data being produced and the different formats can make it problematic sometimes to share. So this is really why, I would say it's not really anything new, but the processes people use are different nowadays. So it's maybe more challenging for them to be open. And I think culturally as well, research is a very competitive environment. So people may feel like, it's problematic career-wise to share. They don't necessarily get the recognition and rewards. And they also, they don't want to be scooped by colleagues. So I think there are a few reasons that there's maybe barriers to sharing, but it isn't really a new concept. in terms of the NREN world and generally, I think open science is taking on greater strategic importance. So when we look at what the European Commission's doing, you've seen all the big investments in EOSC, and there's a number of programs coming up. So the European Data Lake, there's a different kind of thematic data clouds and this idea of a kind of pool of data. We've got all of the investment in AI, technologies like data cubes or quantum network, which is the next big thing really in our space. And it's not even just at this European level, you know, open science is taking a really key role on national agendas. I know many of you have been involved in discussions in your own countries. And I think within GÉANT and the NREN community, you're involved in a number of kind of critical groups. So Catherine, for example, has been the GÉANT representative on the executive board for EOSC. You've got various representatives in governance board and on many of the projects. So things like EOSC Enhance or the clusters or EOSC Nordic. So I think it's an area of growing importance, but also one that NRENs have been very proactive in engaging in. And just a kind of final introductory thing here about the relevance. I wanted to just explain my role at GÉANT. So my job title is EOSC Engagement Manager, but I plan to go beyond EOSC. So I think EOSC is a really important initiative, and it's one that a lot of the community is already engaged in. But actually, I think it's very important that you're involved in national discussions and, you know, the context there. So I have a number of ideas of things that potentially I'll be doing. So helping you provide a coordinated voice within EOSC through the NREN community, helping you connect with or be the National Open Science Initiative in your country, and certain areas of work, like I'm interested in maybe a procurement framework around research data services, because I think that's a big issue for institutions, and potentially as a kind of big European community, we could push services out the way it has been done with the cloud services. So there are, I think, options if you're interested in expanding service portfolios, but that's something that obviously needs discussion with you as a community. So I wanted to kind of open the floor a little bit to you just to try and understand from the work you do or from the events you've been at, what do you all understand by the term open science? I don't know if you want to shout out certain buzzwords. I think at the start, Leonie mentioned about open access, but what is it that you all understand by this concept? And don't be shy, even though we're recording. Drills, do you want to give a word?
I suppose I should. Well, in this context, I think it's very much about data, actually. I think a bit of the EOSC discussion has been sidetracked by services and access to infrastructure, and I think we would do ourselves a great favor if we focused more on providing data on open repositories that are easily accessible, and I think the other parts will eventually come.
Yeah, definitely. Yeah, no, it's certainly in the EOS context, a lot of the discussion, you know, is around the data side too. Anyone else want to offer a observation? It's okay if not. I can move on because I kind of have an answer on the next slide.
We have a comment. We have a comment.
Yeah, go ahead, Magda.
No, there is in chat. We have a comment from Martin.
Okay. Sorry, I can't see the chat. Let me open up.
I will read it out. So lowering or removing barriers to accessing the outputs of research.
Excellent. Okay. From Martin Donnelly, a former colleague at DCC. Yeah. So openness is really about trying to enable wider sharing and reuse of outputs. Definitely. So in terms of open access, a lot of people will initially think about, in terms of open science rather, a lot of people will initially think about open access. So they'll maybe consider the publications, but open science is about a broad spectrum. It's about access to all the kind of outputs or relevant content from research. So it's about the data, as Truls mentioned, it's about being open source, using open source, being open about your methodologies and other things, learning resources, peer review. And This is one definition that I really like. It comes from RIN, and it's talking about open science being science that's carried out and communicated in an open manner. And I think that's what's important. It's about all of these stages of research. It's about the way you're conducting your research, the tools you're using, the way that you enable collaboration and discussion. It's not just about the sharing of the outputs. It's really about that whole process. So I like to think of it, if we have this kind of generic research life cycle that, we're designing experiments, running them, doing the analysis and publishing, it's about trying to be open throughout all those stages. So trying to publish earlier, release things, before you've got to the end of the project and you're releasing your data, actually releasing things earlier, and all the different type of outputs, the papers, the data, the methodologies, code. And this really supports reproducibility, but it supports people to engage with your work as well. And the other thing I wanted to flag, a concept that you've probably come across in this field of open science, is FAIR. FAIR literally stands for findable, accessible, interoperable, and reusable. And people will often conflate these two concepts. They'll think fair and open mean the same, and they don't. They do overlap. They have some similarities, but FAIR is really about the way in which you make content available. So it's about it being documented. It's about it conforming to standards and effectively being available in a way that it can be discovered and reused. So you can have closed data. You can have data that's either under an embargo or restricted in some way or only available to certain groups. So it doesn't need to be open. It doesn't need to be shared in that very permissive way. So that's the difference really between fair and open. And the EC uses this notion of fair data a lot within the European Open Science Cloud work. And I think that's because of the recognition that, not all data can be made openly available, but it is really important that people manage and share their data in whatever way they can. So they have this little strap line: as open as possible, as closed as necessary. So they encourage openness, but they accept that maybe not everyone can get to full openness. And I wanted to just reflect before I kind of pause in case you've got any questions, just on a couple of the challenges. So I've kind of gone over the vision of open science, but what you'll actually find is that a lot of data isn't managed, let alone being open or fair. And I think that the management of data, kind of making sure it's well documented, making sure it's properly stored and shared appropriately, that work that happens while the researchers are conducting their research, they're creating and managing their data before they get to these sharing stages, I think that's a really important precursor. Because if the data is not managed well in the first place, it's very difficult to make it fair and to make it open in a useful way, because your content's not in a good structure and form for sharing. And what I think you'll find when you're engaging with research groups is that unless there's, proper structures in place within that group, so certainly in very large collaborations or facility science, there are procedures and structures in place. When there's not, you'll find there's a lot of kind of like very ad hoc practices. People are maybe storing things on, external hard drives or, their laptops. It's not properly, it's not in managed storage. And I think, my next question is, why is that the case? Why is not very much managed, let alone being open or fair? I think one of the challenges for researchers in terms of open science is that it takes a lot of time and effort. So this is a blog post from quite a few years ago about Emilio Brunner. He works in a lab, and he it literally counted the time it took him to share the associated data and code with one publication. And the opportunity cost was 35 hours, so a working week, plus $690. And this was the charges for archiving in Dryad and the page charges for the publishing. And when you look through this, you see that there's a big learning curve for researchers. So, actually submitting data to a repository is often a new process. So they need to register, they need to learn the repository system, they need to document their data if it hasn't already been well documented. And actually the big effort here was in terms of the code. So cleaning and documenting and uploading the code was a huge amount of time. And the blog post is really nice because it reflects also on, the reactions from the researcher, so the fact that it's actually, you're not necessarily sure you want other people looking at your code because you're not too sure about the quality or it's not perfectly crafted. So a lot of this, I think there's a kind of cultural barrier. And one of the big challenges we face is that the recognition and rewards are not there yet for open science. So in some work I've done in the past where I've interviewed researchers, one of them came out with this quote that it's hard to overcome your personal investment. It's like you're giving your baby away. And I think researchers put so much effort into, the data sets they create, and they want to use them themselves in future research, that it seems a big ask. And certainly when there's not much recognition and reward for going through that effort and sharing, I think this is a big kind of stumbling block to getting more engagement in open science. So that's a little bit of introduction. And I will go on and talk about, some of the practicalities of how to publish open access, how to make your data open. But I wanted to just pause here in case there's any questions or reflections on the general concepts of open science or any of the things I've touched on with the cultural barriers. No? Okay. If there's not, we can move on. That's not a problem at all. So what I want to mention in terms of the kind of practicalities is really to point out some resources that could be useful to you when you're supporting researchers or advising universities. So open access publication, I suspect many of you have come across before. So typically both research funders and universities and other groups will push or expect publications to be made available openly. And there's two main routes to doing this. So you have the options that are often termed green and gold. So green open access is where there's a repository service that you deposit in. You're not paying any kind of processing charge to the publisher. So you can just take a copy of your article, like a preprint of it, so not with the publisher's layout typically, and you can submit that to your repository. There may be an embargo period imposed by your publisher. So it might be that can't become available for 6 months or 12 months because the publisher wants their version to be the primary version initially. But it is freely open, and there's no cost to that. And most universities have repositories. There's lists of repositories that you can search online for this. And then the other route, which you'll see in many cases, and this is what publishers will often push for as well, is this gold open access. So when it comes to publishing, they'll say, okay, well, if you pay us an article processing charge, we will make that article openly available for you. There's no need for you to do anything else. The fees for doing that really range a lot. Sometimes it's several thousand. Some universities or funders will make support available for this. So there may be an APC fund that researchers can tap into. But it isn't necessary to go down that route. There is an entirely free route as well through just depositing in a repository. There's a really useful resource that comes out of GISC called Sherpa Romeo, where you can see all of the relevant conditions. So you can search for the specific journal you're depositing in, and it tells you exactly, what the publisher allows, which, whether there are set embargoes and what you're allowed to share, which version of the article. And then there's also a useful resource called Open Door, which lists all the available repositories. So researchers can search for repositories in their country or by, their field, because there's big repositories like Archive, for example, that could be used if you don't want to use your institutional repository. And there's also a really nice tool, Open Access Button. What researchers will often find is that they hit a paywall. So they're searching for a particular article and maybe their university doesn't have a subscription to that article, and they find that they can't get a copy of that literature without paying separately for that. An open access button, you can install it in your browser. That will literally then search the various repositories to try and find you an open copy of that article. And if that's not available, it can ping the author and recommend that they make it available somewhere because people are looking for it on open access. Now, In the next Infoshare, Irina Kuchma will give you a whole overview of open access and various tools and services that are available from groups like OpenAIRE. So this is really just a very basic overview to some of the key resources and, essentially what it means to publish open access. The next thing I wanted to touch on is open data. So again, we're seeing that funders are increasingly asking people to make their data available and ideally openly. But this will never apply to all data. So there are various data sets that can't be shared. Maybe they've got sensitive material in there, they're about human subjects and it's disclosive and, you have to have restrictions on the sharing, or it might be that, there are commercial parties doing the research with you. So there's trade secrets or some kind of, reasons why the data can't be openly available. What you'll see with funders is that they generally apply the principle that you should begin with the data that underlies the publications. So you should always be able to evidence your research results, as I mentioned at the start. So you should be able to make the relevant data to kind of validate those findings available. And that's the kind of starting point. And then ideally, you'd share more data than that and you'd be as open as possible. And I wanted to flag this 5 stars of open data from Tim Berners-Lee, because it shows you essentially that you can make your data more useful by doing different things. So technically, any content that's available on the web under an open license is open data. So we could make, there might be like a table of data, so, like a spreadsheet, and we could make an image of that available. Now, that's not massively useful because it's not structured data. People can't reuse that. They'd have to re-enter the values if it was just an image of a table. And it might not be in an open format. If we use certain proprietary formats, people might not have the software to read that content. So what you see in this 5 stars of open data is ways that you can essentially make your data more reusable. And this is similar really to the concept of FAIR. So FAIR is also a scale. It's not a case of my data's fair or not. It could be increasingly fair. It's different levels of fairness. And here, in terms of open data, the things that are important is making it available in a structured way, in a useful open file format, using URIs and linking your data. So it's about the richness of the context. And when you look at the FAIR principles, it's very similar things that come up. So at a base level, your data set, to be fair, should have identifiers, it should have some metadata. But again, ideally, you'd be using relevant standards, you'd be adding rich context to make it reusable. And in terms of the practicalities of how researchers make their data open, these are 4 steps put forward by the Open Knowledge Foundation. First off, it's to decide what data set to share. As I mentioned before, not all data can be open. So it might be that a research group wants to share something and then they find that they don't have permissions or they're not able to for whatever reason. So they may need to come back to this step. And then once you've chosen what to make available, you apply an open license. In terms of data, things like Creative Commons license work, ideally CC0, which is a public domain license, or CC BY, which is attribution only. For source code, you'd want to use different licenses like MIT, for example, and CC BY is not as good for code rather. And then you make your data available. And ideally, what you'll see in certain funder policies is that they push for researchers to use repositories. And that's because those repositories, will have a mission to keep that data available. They'll know the relevant standards for that discipline, and they'll make sure there's suitable metadata that ideally can be harvested by other services. So by using a repository service, it means that the data is more accessible and it's going to be managed properly long term and is registered in catalogs, so it's discoverable online. So those are the kind of key steps to point out to researchers if they're trying to make their data open. And then, yeah.
Is it enough just to write to your next to your data CC BY, or do I have to register something, or do I have to do something with this license?
So So in terms of making data available, if you're using a repository, there will usually be a field that says what's the license that applies to this. And then you can pick CC BY so that it applies that license. I mean, technically you can just state it. So like on these slide sets, I might just put like the CC logo on the front and say under CC BY, but that's not as machine readable, like it's not clear that this is the license that applies to these slides. You'd need to be reading that as a human to see it. So ideally you'd have it structured in the metadata to say what license applies. And that's another good reason to use repositories, because they will have a field for the license.
Okay.
Yeah. And actually, one thing I didn't mention there are certain license selectors. So if you're not sure what license is most appropriate for your code or your data, there's a link I can add into chat, UDAT licensing wizard, that can walk you through the different options. And then in terms of open source code, there's a lot of good practice through certain groups that I've linked to on the slide. So the Software Sustainability Institute and the Research Software Engineers community. They've got various guides on, how to document your code, how to make it available. And the RSE, this is essentially a group of professionals that are really defining the roles of professionals in that space and trying to build career paths. So you'll find that there might be software engineers at different institutions that you could draw on for support. There are tools that are relevant here as well. So GitHub, for example, and Zenodo have an integration. So if people have, their code on GitHub, they're able to publish to Zenodo. And then each time they do a release or whenever they want a new version, they can mint a new version of the DOI as well. And in terms of the practice that we see, I think the kind of being open with code and properly documenting code occurs most where there is like dedicated support in the research group. So either there's a research software engineer in place, or a data steward, or an RA who's kind of focused on this and doing that work. I think the practice is very ad hoc, in many cases otherwise in individual research groups. And this kind of reflects on what I was mentioning before, that opportunity cost of open science. I think sharing code is often like an extra step for researchers, and one that is quite new and something they're maybe not entirely ready for yet. And just to reflect on that, I wanted to share these kind of statistics from a survey that the Software Sustainability Institute did in the UK. This was a survey of Russell Group Uni, so the big leading research institutions. And they found that, most people, 92%, were using research software. And if they didn't have that research software, it would be impossible to do their research in most cases, or very difficult, but probably, still feasible. So there's kind of a ticking time bomb here, because when you look at the other statistics, 56% of people are developing their own software, and most of those have no formal training. And we've seen that, the practices around research software are, not as advanced. So I think this is a real area where we need to do more work. It's something through the EOSC work. I don't know if people will know, Jean-Francois Abramatic, he's a computer scientist who's on the executive board. It's one of the areas he's really been pushing for the next funding, next framework program, because we don't really have enough support and enough good practice in this space. So hopefully that's something that there will be more calls and more investment in. So in terms of where we're at with open science, I think there's a really quite good progress on open access publications. I think people understand the concepts. There's a lot of infrastructure and support within universities on this already. In terms of data, there are lots of policies from funders, and there is a fair bit of headway, but not as much. I wouldn't say it's as advanced as open access. And also it's more problematic. We have a much bigger range of data types, and it's more complicated for people to share their data. And then in terms of the other areas, open source software, open peer review, open methods, and kind of sharing practice as research is going on, I think that's even less advanced. So it's really open access where things are, more gained more traction so far. So there's still a big cultural change needed to make open science the kind of new norm. And there's a lot of work going on in this space through EOSC and through various national initiatives to try and achieve that. So again, I'm going to just pause in case people have questions around, the practicalities of supporting researchers with open science or some of the resources. And then we'll go into the last few slides, just thinking about the role of the NRENs. So does anyone have anything they want to pick up in terms of the links that I've shared just there or the concepts? Lars?
Yeah, so there's a lot of stuff here that is super important, but it's not that clear how NRENs can contribute, and I realize you're going to talk about that next. But it was pointing out that there are a couple of NRENs who have found places to do stuff. For example, FUNET CSC run summer schools, and some of these are run at Nordic level by Nike and so on. So there are summer schools in how to do software development, how to do open source for researchers. So they're not meant for NREN staff, right? They're meant for
for the research community.
Yeah. So they can come and spend some time.
And actually, this is one of the things that really interests me, because I'm slowly learning about the NRENs and the work that you've all been doing. But it seems a very, very different landscape in each country based on, the kind of priorities the NREN has or the different skill sets that you have. And I think in certain groups, like in the Nordics, for example, with groups like CSC, they've been very engaged in that data side of work through projects like UDAT. So, I think there's, in certain places, there will be easier links to then do training with researchers or to do different things. And what I'm keen to kind of pick up on is where GÉANT can play a role and help you in that. So maybe if I go into these last couple of slides, the first one, I wanted to just reflect on what's happening at a national level. I think in various countries, there's a fair amount of work. So many countries have national strategy or policy. So for example, in France, there's a national open science plan. In the Netherlands and the UK, they have a kind of strategy of what will be developed at the national level. And sometimes there are policies like the UK Concordat. So there may be a very kind of coordinated strategic level investment in open science. And I think from my perspective, where that kind of discussion's happening at a national level, it would be really good to make sure the NREN's involved or engaged in that discussion, because, the network's a big part of provision. And I think, all of this data is flowing over the network. So it's good that you're involved in that if there's interest there. There's also in a number of countries an open science coordinator role. So in the Netherlands and France and Finland, and now in Ireland as well, there's a specific person funded to try and coordinate the national work. So to drive that policy agenda, to look at where different infrastructure investments are being made, and to try and, kind of make sure that those are joined up. And the vision here is that these coordinators, will engage in a forum. There's a forum called CONOSC, and that they can then help each other and kind of make sure that what's developing across Europe is more coherent. Obviously, you need to meet national agendas and the differences in each country context, but I think that forum will be a really useful way to share skills if there is going to be a coordinator in your country as well. There are also various groups that are engaged in open science or data initiatives. So the Research Data Alliance has a series of national nodes, and in many of your countries there will be an RDA node. There's probably also an open access desk, a NOAD from OpenAIRE. So there's probably some people who are engaged in this area of work already, that again, if you're not connected up with, it's useful to reach out and to see what potential collaborations there are. And in some countries, they have set up national discussion forums. So in Denmark, for example, there's been a National Research Data Forum running for several years now that Dykes coordinated, but there's national groups in other countries too. And a number of countries have invested very heavily in infrastructure. So Leonie will be aware of, the NFDI initiative in Germany. In Switzerland, they had this data lifecycle management project, which has had a couple of phases. It's now going into its third one, I think. And in Austria, there's e-Infrastructures Austria. So often there's a big investment in the infrastructure at a national level. And also in terms of services, there may be, national DMP tools like there is in Finland, or in Italy, they had a coordinated approach to their research information management systems. So there's often a lot of work going on in the national level. And I think it's interesting to consider, where the NREN either is already engaged or could be engaged, or work that you're doing that aligns with this. And as part of my kind of landscape analysis and background research, I looked at the compendium and pulled out information about collaboration services offered by NRENs and also professional services, and tried to pull out where there were things that, touch on this kind of research data, open science agenda. Now, I'm conscious some of these services may not be used for data. They could be used for anything. So they may be used in slightly different contexts. But out of 43 NRENs, there's a huge amount, doing relevant work. So things like the file sender or the IaaS services or cloud storage, a lot of training and consultancy. And again, that may be in other contexts in open science, but the fact that there's already a lot of delivery around there may be opportunities to pick up on, like the training for researchers, as Lars was mentioning. Lots of work around things like software licenses and identifiers as well, which is, again, very relevant for things like FAIR data. So what I have been doing in terms of my work is pulling together potential areas of work for NRENs in terms of open science. I want to do more consultation with you as a community to understand what your main interests are, and then to develop a program of work. So as I mentioned before, I think it's really important, personally, that you're involved in those discussions on a national level, because I think, it's open science is a big new area of work, and I think it's quite relevant to the work that you do in the NREN community. And potentially there's things, that myself and colleagues can do to increase open science skills. So like this session, or like the other ones that we'll run, or training that we could do to help yourselves and other colleagues in NRENs, play a role in that open science agenda if you're interested in. So, being able to advise the universities and the research communities, potentially acting as like the national hub on open science. If there isn't an RDA node, or if there isn't an open air desk, maybe the NREN could offer a base for that. Because I think one of the real strengths of your network is the fact that you do have a strong organization in every country. So it's a very robust community, sustainable community. And I think that makes you well placed for providing a home for things. As I mentioned before, I'm also interested in exploring options for a European-wide procurement framework for data services. One thing I've seen a lot from the university perspective is that they're often outsourcing for things like their CRIS system or lab notebooks or their repositories. And for a single institution to, go out to tender and, try and select a provider, it's a much harder process, and they don't necessarily have the same clout to secure the better deals, and they may not get, as good academic terms. So I think, given that we're seeing certain providers, being taken up in a number of institutions, it would be quite interesting to see, which services are being used most, and whether there is an interest on trying to do a European-wide framework there. And I think GÉANT's got a lot of experience in that, and also, precedents around things like the cloud storage, that could potentially be a way to make it easier for people to get certain data services that they're using. There's a model, I don't know if anyone from JISC is on the line, but there's a model from GISC here. They've got a dynamic procurement framework, which is looking at their data repositories at the moment. And I think they've got 6 or 7 providers on that. So it makes it a lot easier for institutions because they can then just do a kind of a mini competition. They're not having to go through like all the steps of, you know, essentially checking the provider has all the relevant criteria. And it may be that certain NRENs are also interested in delivering data services. So I know many of you have things like Research Drive or, you know, some kind of cloud, kind of Dropbox-like storage. And some international groups like Sabera over in Alberta, they are also involved in kind of installing and setting up services for institutions. So it may be that there are certain areas of work that you would also like to deliver, and potentially that's something that if there's similarities across NRENs, it might be something that there could be a bigger collaboration on. I also think it's important that we look at the research community angle, not just the national angle, because there are lots of, you know, big collaborations like ESA and Copernicus that go across a number of countries. And I think again that's a way that GÉANT and the NRENs collectively can help deliver value, because, you know, those research collaborations, they don't, you know, they go across border, and it's much more international than, you know, just the country perspective. So those are some of the areas of work that I'm interested in engaging in over the coming year or so. But that's all I had to say today, not too much on the slides, but hopefully it's given you a basic introduction to what open science is and the general concepts, and also, you know, where it potentially could go in terms of GÉANT support for the NRENs. So I'm happy to take any questions, whether it's about open science specifics or work we would do together collaboratively. Thank you.
So I don't see a raised hand, but I have a question. What is in it in open science for the researchers? If researchers publishes something on an article on Nature, so he's well off, he gets a lot of credits. Is there something similar on the open science world? Is there a similar journal with a similar prestige or data repository with a similar prestige when he publishes data on this journal?
Yeah, so I think there's not that same analogy of, you know, this is the leading journal. There are certain data journals. So there are places that rather than being, you know, about the publication, it's about the data. So you make data available, and the publication that accompanies it is really a description of the data. So it's a way to make that more reusable. But I think the real benefit for researchers is how much people can do. You know, there's like much more impact with your data. With a publication, somebody can read your results, they can agree or disagree, they can quote you and cite you. But actually, with your data, they could do entirely different research, or they could do something that's fundamentally, you know, really advancing an area. So that I would say is like the bigger impact and the benefit for researchers. I think the real difficulty is that, you know, culturally it takes more time and effort. There's a lot of concern that researchers have about sharing, you know, they don't necessarily see those benefits. So I think the culture's still kind of growing at the moment. But you do see examples where, you know, a certain community like astronomy, or, you know, like some medical communities may just decide, you know, we aren't going to solve these problems unless we come together as a community and decide we're going to make all our content available. So you do see certain groups where it's part of the common practice that data just becomes readily available, and that's just how the research works. And there are examples of, you know, some of the economic benefits. If I think about the NASA Landsat satellite imagery, that used to be that you'd be charged, you know, per image to use it, and then they made that content openly available to everybody. And actually the reuse, I think it went up tenfold or more, how much that data was being used, but the economic benefit was huge. It was, you know, millions of dollars, because there were new companies that set up using those images. You know, I think they were used on, you know, Google Earth, and like the reuse of the data is just so much higher when it's openly available.
Okay.
Other questions from anybody?
So satellite images are one of the people dealing with satellite images is one of the group well advanced in open science. The others are the social scientists or physicists also.
Yeah, I think one of the issues in terms of openness, so for the social sciences, often people are working with human subjects. So, you know, you have to protect that person's sensitive data. So you have to either anonymize or de-identify the data before it can be shared. And I think there's generally just more caution with that nature of data, because people may have done interviews or something that, it's more rich context. It's not a series of numbers, that's very kind of abstract. So I think people are concerned about the openness. There's still a history of sharing. Actually, social sciences, probably the CESDA network of social science repositories, I think it's like 40 or more years old. So there's a very strong tradition of sharing, but not always in an open way. So there's probably a data sharing agreement or some kind of restrictions on exactly who can use the data or for what purpose, or at minimum people have to sign a data usage license. There has to be like a agreement that you're not going to try and identify individuals or use the data in an inappropriate way. So there's still strong sharing, but not necessarily fully open sharing that you would get with the likes of astronomy data.
So there's also a case here where there's one side where it's the researchers sharing data. Right?
Yeah.
But there's also lots of instances where it's actually the research facility.
Yeah.
As a society, we have spent huge amounts of money on research infrastructures, these very, very expensive instruments. Astronomy as an example, while we're sending the Hubble Space Telescope into space, cost a lot of money. And so as a society, we can say that we grant researchers access to these instruments, use them for the research, but we retain the right to share the data with other researchers, because it is really about the reuse of the data and the extra value we as a society get for our investment there, right?
Yeah.
So for some of the bigger sciences having instruments like that, we can make that claim. I think there was a study from the Hubble Space Telescope some years back. In astronomy, they have this tradition that when you get a grant to use an instrument like the Hubble Space Telescope, you write a research proposal, you get a time slot to use the instrument, and then the data is yours for an embargo period, typically a year, but it can be half a year, it can be 3 years, but it's typically a year, so that you can get to write your article and get your Nobel Prize before anybody else gets the data, right? But after that, it becomes public.
Yeah. Yeah.
And the Hubble Space Telescope did an analysis where they documented that 1 in 3 papers published based on Hubble Space Telescope data is written by the people originally commissioning the images, right? The people getting the grant to get the data. 2 other of the 3 papers are written by people who reuse the data later. But that is enormous economic impact, right?
Completely.
And so there will be more and more instruments that do that, right?
No, and actually, I think things are much easier at that level where you have, a big investment in an instrument and you can set up all of those processes and procedures, so it's part of the terms that you sign up to when you come and do your particular research experiment, that this data is going to be available. They already have it in a way where it's automatically stored, it's shared. So it's not down to the individual researcher to define that and to actually implement it. And I think that's one of the key differences, when we're looking at the long tail of science, and it's like on individuals to have to do all of this extra work.
Well, it's a matter of field work, right? At the Danish National Museum, there are researchers who travel, throughout Siberia and, get genetic samples from indigenous people who lived there 1,000, 2,000, 3,000 years ago and try to document people movement and the evolution of the human race, essentially. I mean, that is individual researchers who go out there and you know, spend their summer after summer in the middle of the, or in Siberia. And there is no instrument. It is their samples and it is their data, right? And I think the big challenge I've experienced talking to people, these people, is when you have that data is your ticket to get to write a paper with the really famous professor from, you know, some other university, right? They wouldn't maybe let a young researcher work with the, you know, Nobel laureate or whatever it is, right? But if you have that crucial data, they will collaborate with you. So it's a ticket. It's really, really important for your career, and you're not going to share it with anybody.
No, exactly. And I think this is one of the major challenges, that it, you know, it is this fear that you're not really going to get any recognition and benefits. You know, at the moment, there's a very strong push on the policy side, and many funders are investing in the infrastructure. But actually, unless we change the incentive structure, unless we actually start to assess researchers on, you know, the sharing of their data, or, you know, give them much more credit for reusing other people's data, not creating new and hoarding, you know, then you're not really going to change that. Because we're still, like, if I think about the UK research assessment exercises, you know, technically for a number of years, you've been able to submit other output types. It's not just publications, you can submit data, code, anything. But the culture and the practice is still to always want that leading Nature paper, that big hitting 4-star paper, because that's what people know, that's a safe thing to put in.
That's how you get tenure.
Yeah, exactly. Until we start to change some of these things, you're not going to get the change in practice, because it takes the outliers, it takes the people who believe in it for whatever reason. They're passionate about open science, or they've had a good experience themselves. They've maybe had new research collaborations form because they made something available openly. So that you'll get some people who really are advocates and push things, but until you actually change the structures, the way that you assess, you know, researchers, you know, give them career paths, unless that changes and really incentivizes it, it's very difficult. Because at the moment, it's harder for people to be open and to manage and share their data than it is to not do that.
We have the same challenge with software, right?
Yeah.
Lots of software used in research cannot be software written by just a computer science guy, right? Because you have to have that really in-depth understanding of quantum chemistry or whatever it is. So it's real researchers, you know, from that field, who spend probably a lifetime writing specialized software to do, you know, the software that enables groundbreaking research, but they don't get the credit.
No.
Even though the science couldn't be done without them. And it's, you know, when we talk about, we talked before about lots of researchers writing code, but few of them have any formal training. And part of that is also because we don't have an incentive structure for people being software developers inside science, right?
Yeah, no, exactly. This is exactly what the RSE, the Research Software Engineers Group's trying to, you know, change the paths on, to recognize the skills of these people and to actually, you know, start to give them ways to actually build their career, rather than them being this kind of lone person, you know, in a group, in a very fragile, unstable contract, and not having a peer network and not being credited for that work. You know, because they're like listed whatever 50th on a publication, but like you say, that entire work wouldn't happen without the code.
Being forever employed as research assistant on 6-month contracts, right?
Exactly.
So I think that leads to in that discussion about where is it NRENs can contribute, right? Because I think it's obvious that open science isn't as such at the core of what we do, but we support science. So it's about, you know, also to point, you know, usually we think of NRENs supporting science by moving data or maybe storing data. Here it's about supporting processes, and how it's about figuring out how can we do that. I know Lena and Tulsa here, they can talk about what DIKE is doing with data management. There must clearly be something we can do about helping researchers who are not experts and would rather do research and manage data. So maybe we can offer tools for that. Also, I was thinking about open access publication and stuff like that. Maybe at least we can offer tools. And the same for publishing data to repositories. Maybe NRENs can make it easier by, you know, having a tool set that you can download that makes it so you don't have to have that learning curve of figuring out how the hell do I publish my data to the right repository, or how do I get to the right repository. Maybe the NREN can, you know, be the intermediary to help do that.
Yeah.
And I do think with processes for open source code, we also have some expertise, right? So there's also things we can do, again, providing tools and training.
Yeah, no, definitely.
Those are sort of the things I can see. I think Lena started a video, so maybe she has something to contribute.
Yeah. And I think just to reflect quickly on that, I think also because you're effectively like the intermediary between GÉANT and the institutions, so you're in that national space. I think universities have a lot of kind of queries or needs for support to help researchers with this. So exactly around, having the appropriate tools and services in place. So potentially there are things that you push out and support institutions to operate. But Lena, do you want to speak up?
Just a comment. I hope my sound is okay. But
yeah,
I fully agree. I fully agree with Lars, and I think we should keep in mind that from a researcher's point of view, they don't distinguish if a service comes from an NREN or another provider. I mean, we need to join forces in making it as easy as possible for the researchers to pick their tool.
Yeah.
Then we can have for sure the back office where we are teaming up as service providers and agreeing how to create synergy and so.
Your sound's flaking in a little bit, in and out a little bit. But I think you're completely right. Researchers don't really know where the service comes from, and I don't think they care too much. They just want to know it works and is effective and does what they need.
Okay,
so
great.
Questions, Sarah, if you could comment on now is one of the founding members in EOSC Association. Could you elaborate a bit on
so you asked about the members of the EOSC Association. Was it about the number or? Do you want to type that in chat? I don't know why your audio is flaking in and out.
GÉANT being a founding member of
about
EOSC.
GÉANT being a founding member, yeah. Okay, so so there were 4 founding members, and really this was just for practicalities reasons. You need 3 to go and get all the paperwork signed with the notary, and we did 4 just in case there was somebody that for whatever reason couldn't attend at the time, given all of the climate we live in at the moment. So GÉANT, let me just open this up in chat. So elaborating on that. So the choice of the 4 founding members came from the current exec board and governance board, and the exec board nominated Cesar and GÉANT, which are the 2 kind of vice chairs, the chair and vice chair of the current exec board. And the governance board, so the member state kind of body, nominated Italy and Spain. So that's GAR and CSIC, CSIC. I don't think they pronounce it CSIC like me. So they're the 4 founding members. And technically, aside from doing more work currently and setting things up, the founding member doesn't have any privilege. So it isn't that the founding members get to decide on certain terms or how EOSC works. That has to be done by the association as a whole. So at the moment, GÉANT, Catherine and myself and Magdalena Schacher, who's the legal expert in GÉANT, are involved in doing various things. Setting up the bylaws, setting up the first General Assembly, pulling together the job description for Secretary General so that we can get all of those things in train. There will be a preliminary General Assembly later this month. I think, I can't remember the date, 28th of October maybe. And that General Assembly is literally just for the founding 4 to review the membership and to approve other members, so that then we can have a much wider group that actually takes all the decisions on, the election of the board and, any approving the bylaws or anything else that needs to be established. So at the moment we have, I think it's 90 or even more than 90 applications for the EOSC Association. Most of these have been reviewed. It's the Spanish partner CSIC that's done most of that work. And I think pretty much everyone's been eligible. There's only occasionally cases where we said that, you know, you have to be a legal entity to be a member. The statutes state that, and you know, ministries can't be a member, for example. It has to be a body in their country. So there's occasionally cases where we can't accept a member, but there haven't really been many major issues as far as I know. So what's likely to happen is that all of these will be accepted, and there'll be a General Assembly in December. And GÉANT, I think it's good that GÉANT's a founding member. It means that the NREN community is represented. So, you know, in any future discussions, if you're not a member in your own right, then obviously you can certainly feed in views through GÉANT, and have a say in the EOS discussions that way. But I mean, there's nothing, you know, to stop any NRENs being members themselves. I know several are, and actually some of the NRENs are the mandated organization for different countries as well. So Belnet, for example, is the mandated organization for Belgium. Hopefully that covers what it was you were interested in. Yeah, super. So any other questions people would like to raise or observations around open science or the role for NRENs? Truls?
Unmuted myself.
I can see no more raised hands. No.
Oh, you just see all your books. Ah, here we go. You've appeared.
Magic. No, I don't know if you can answer this, but there's a lot of sort of treating scientists as individuals and the EOSC as a marketplace where they can tap into different services and resources. Whereas I think the main motivation for scientists is actually how can we work collaboratively across borders, funding structures, organizations.
Yeah.
And I think actually more than sort of individualizing the service that we provide, we should focus more on that in EOSC. I know that GoFair has been the FAIR data manager for the global COVID-19 data. So I mean, these kind of, and that actually refers back to the whole point of open science is how can we structure open science in an open environment with different partners, with different data, using their own data and proprietary resources and all that. And I think that is actually more interesting for the scientists that want to do these large-scale community-driven research projects, rather than having to find 10 iterations of the same service across Europe.
No, completely agree. So I've always been an advocate of approaching things on a research community basis. So my very first job was working in a subject-specific data repository. And I've always found that researchers' kind of affinities and affiliations are with their domain, their space. And it's not institutional, it's not even national, you know, it's like they have as much in common with researchers in a completely different country or continent than they do necessarily with other people in their own institution. So I think you're right, we need to work in that kind of research focused way. And I think this is coming up in the EC's agenda. So they have this, the data spaces. I think if any of you are attending the workshop we do tomorrow, the EU liaison and project workshop, you'll see a bit in the EU liaison content around the European data spaces and this data lake notion. And I think, you know, trying to have data spaces kind of more thematic around certain research groups or collaborations, but also harmonizing across those so that there is the opportunity to be able to exchange data is a much more useful approach. I will admit I am a bit of an EOSC skeptic. I think some of the ways that EOSC has been delivered so far are not ideal. And I do question some of like the marketplace notion and this idea that, you know, researchers are going to come and, you know, be procuring and buying services in that very individualistic way. So I think the visions of open science, you know, are right. And I think the vision of EOSC is right. But I think we've maybe, you know, hit some stumbling blocks in terms of implementation. And I think actually much closer collaboration with the research infrastructures and the research communities is key, because unless we actually have, unless we federate the data and actually have, content that people can discover and reuse, it's not valuable. So I don't know if that answers your question, Charles.
Yeah, well, no, I think we share some ideas, at least, yes. A major concern when we talk about sensitive data is that right now there's a lot of skepticism about GDPR and EOSC as some way of closing off access to working together with particularly US universities. And it's really hard for PIs to manage data in collaboration with American scientists, and I think that needs a lot of work.
No, I think I must admit the legal barriers are ones that I'm not all that concerned on myself. So in the FAIR working group, we actually got we did a consultancy to bring legal experts in, because none of us felt appropriately skilled to be, making legal recommendations for EOSC. But I think that is a huge challenging area, certainly with like the European GDPR regulation and, the differences in other continents. Lars, I know you've done work on
so Troels and I have been
on that.
collaborating on work on that. And one of the things that we found interesting is that often the barrier is not, so by going and talking to researchers, investigating actual use cases, that often the barrier is not really the legal stuff itself, it's not really GDPR, it's the fear of it. Or it's the internal processes. So it might be actually legal to share the data, but the owner of the data set for medical research might be a hospital in Denmark, and they've been asked to share it with a hospital in Norway, or researcher in Norway. And they think it might be legal, or lawyers said it might be okay. But, but on the other hand, there was this time last year where we ended up on the front page of this newspaper, and it didn't look really good. And there's an opportunity cost. If we share it,
definitely.
If we share it, it's great for the researcher in Norway. If it goes well, if we
risk,
share it and it goes badly, it's really bad for us, and no loss to the researcher in Norway. So why don't we say no?
Yeah, and actually, do you know, when you look at institutions as well, they're so risk averse. So if you have the institutional lawyers recommending things on that, there's no way they'll have you sharing it.
It's the same reason that American newspapers, when you browse into them from a Danish, from my home, right, you get because of GDPR, you can't reach these sports results from Dallas, right, because people are just afraid of it. Right? It's easier to say no. The other thing we found is that often researchers don't have the support. Right? They go to the legal department, but the legal department at university, they are experts in procurement or employment legislation or finance stuff and stuff. They don't really have people who are experts in data sharing, right? So they're not sure. Nobody really at the university are able to give, even on bigger universities, are able to give good advice on this. So that's a real barrier. That maybe is the true legal barrier more than legislation itself. Right?
Yeah, I actually think this happens in two places in terms of data management and sharing. So in terms of ethics and consent agreements, and also in the legal aspect, like you've just been describing, because within institutions, researchers are, kind of getting advice from various different groups, and that advice often conflicts. So when, they go and get their ethical approvals, the standard consent agreement will often say something about, we're collecting this data for this research, and afterwards it will be destroyed. Now, it's not necessary to make that promise. And in many cases, it's not actually desirable. The researcher may want to use it themselves in another project, or, they may be on a funded project where the funder expects them to share that data. But then at the end of their project, they get to that stage of sharing and they find that they don't have any permissions. They don't actually have the right to do it. So often there are things that are at odds and, putting up barriers to actually doing the sharing. And the same with the legal aspect, exactly like you say, lawyers will, be averse to, the risk of a GDPR breach or doing something that technically is, illegal. And I know myself, when we've offered services, in other countries, like in my past job, we ran the DMP Online service and hosted it for various different countries or groups. Sometimes the GDPR statements we were asked to, or liability clauses we were asked to sign were just ridiculous. It's like, there's absolutely no way, even if there was a breach, the actual cost to the organization of that breach would be nowhere in that region, and it's just things that a university couldn't ever possibly sign. So I think sometimes the advice that you may get from certain groups, like the ethics or the legal teams and institutions, then it doesn't really help what the research is trying to do and the objectives there, because they're coming from very different angles. And typically those central service functions in unis are very risk averse and, and not in line with the research policy from funders about sharing and being open.
So I don't want to hijack this meeting to be about this particular topic, but I do think it's relevant in the sense that we have a tradition in the NREN community about forming groups and giving advice and helping you with process issues. So maybe this is an area where we can work with our communities and have discussions and our national conferences and stuff like that about how do you manage these things? How do you make sure that the IT department or the legal department at university can not only just advise you on which file system to pick for your research data, but also advise you on legal implication of sharing it, right?
Yeah.
And who to talk to, which we want to share, right? So,
yeah, definitely. And I think as I said before, one of the strengths of the NREN network is that you have a base in every country, and you've got a really strong community, in terms of the events and the things that you do together already. So I think if there is, advice that could be offered there, that's something that it could be developed by a small group of NRENs, but it could be applicable to them all. And then you've got a series of advice or trainings or guidance that can go out. So I think definitely areas of kind of shared interests like that are worth pursuing. So in terms of the time, we've got 15 minutes left if there are other questions, or I see Annabelle's just joined if you want to say anything.
Thanks for pointing that out, Sarah. No, I'm sure it's been fantastic.
No, it's been good. We've had some chat, and obviously this has been recorded so people can see the slides. And actually the slides are on the wiki already if people want those, and I'm happy to take questions at any point. If something comes up at a later stage and you're not too sure, by all means email me.
Okay, then I would like to thank you all for your interest and your time, and I'm looking forward to see you at our upcoming InfoShares for next month. It's
Excellent.
marked up. Which date is it? 4th of November.
Oops. Yes.
Yeah, so November 1 is going to be Irina Kuchma on open access and explaining some open air services. I can't recall the date. Is it 4th?
I have it now. Yes, it's 4th of
Oh,
November,
okay.
which is still Wednesday from 2 to 3:30.
Excellent.
Then the third principles we have on the 2nd of December.
Mm-hmm.
And the final RTM and GÉANT is on the 13th of January.
Excellent. Yeah, and actually, obviously we've got these 4 scheduled, but if there are other things that you think should come up as topics or other things you'd like to see in the series, let us know as well. Excellent.
Okay, well, thank you for your time.
Thank you all. Have a lovely afternoon.
Bye.
Sarah, cheers.
Bye-bye.
bye-bye.